Okay, Unit 3, Lesson 1, we're doing rational expressions. Remember, a rational expression is fancy for a fraction that has an integer in the numerator and a denominator. You just can't have 0 in the denominator. That's what this little extra thing up here, identify the values of the variable that must be excluded to prevent division by 0. Sorry, I was copying and pasting from the good old modules. So anyway, you have to practice and follow the rules from 3rd grade. Today we're going to reduce algebraic rational expressions, and tomorrow we're going to add them and divide them and multiply them and subtract them, just like you did in 3rd grade, but one thing at a time. Here we are, example 1. Reduce the following rational expressions to lowest terms. Identify values of the variable that must be excluded to prevent division by 0. Okay, first things first. Let's go back to good old 3rd grade, and here we have 6 over 24. Now, most of you can go, oh, that's 1/4, Mrs. Trulin, in a heartbeat, because you've been reducing this fraction since you were in the 3rd grade. But really what you did in 3rd grade was factor. I hate how they say goes into. What goes into this? If they had just used the right word from 3rd grade, factor, you wouldn't be panicking right now every time I say the word factor. So what you did was think 6 and 24. 6 factors into 6 times 1, 24 factors into 6 times 4, and then you crossed off the 6's because 6 divided by 6 is really 1, and there's your answer of 1/4. Well, it's the same thing with an algebraic fraction, except we don't use goes into, what goes into x squared minus x minus 6, that goes into 5x squared plus 10x, because we don't know what goes into, so we have to investigate. So we have to do our favorite thing in the world, which is factoring. That's why you have to know your factoring rules. This is a quadratic, so I'm going to look at it as a trinomial and realize trinomials can factor into binomials. Two numbers that multiply to 6 that are 1 away from each other, 3 and 2. It's got to be a negative and a positive in order to get the -6 and the -1 in the middle. Now this should all be very easy for you, and I don't need to go over how to factor. 5x squared plus 10x, I'm going to do greatest common factor first, as I always do. That's 5x, and what is left? X plus 2. Well, there you have it. Just like we canceled out the common factor of 6 over here, we cancel out the common factor of x plus 2, and we're left with x minus 3 over 5x. Now the last thing it asked us to do is identify the values of the variable that must be excluded to prevent division by 0. So in other words, we just take our beady little eyes and we look at the denominator. What would x be so that if I put it in, multiplied it by 5, I got 0. So in essence, all you're doing is setting the denominator equal to 0. So x minus 3 divided by 5x is a legal fraction as long as x does not equal a 0. Because if you put a 0 in, you will get an undefined fraction. All right, so we're just going to have actually three little division problems. So this is a fraction or a division problem. We want to, as always, reduce. So to reduce, we factor. Well, the top doesn't look like it can factor, but the bottom is a difference of two perfect squares. And now on the top, we have 3 minus x. So our brain should be thinking, hey, 3 minus x and x minus 3 look a lot alike. So I can do one more factoring. I can, on the top, take out a greatest common factor of -1, which will leave me with -3 plus x. If you remember this from 8th grade, that turns into really x minus 3 minus 3. So therefore, this is a common factor that can cancel out, and I'm left with -1 over x plus 3. And the restriction is that x cannot equal a -3. Because if I put -3 in there, I'll get a 0 in the denominator, which is illegal. So example 3, the last one, is a little tricky. If you look at this, you have 2 terms on the top and 2 terms on the bottom. So I want to combine this so it looks like something I can factor and reduce. I hope you can take the shortcut and realize that there is a greatest common factor between the first term and the second term. That greatest common factor is 2. And when I pull a 2 out, I'm left with the x plus 1 plus, if I pulled a 2 out of here, plus 1. And if I clean that up, that becomes 2 times x plus 2. Now, if you didn't see that, you would get the same answer. You just might have taken it the long way. Well, the long way would look like this. You distribute the 2. You realize that that can get combined to 2x plus 4, and then you realize that it's the greatest common factor of 2. You may say, well, Mrs. Trollen, to me that's the same amount of steps. I don't care which way you do it. Just learn one way. The bottom, well, that can get cleaned up also. No shortcut here. I'm going to have to double distribute this out. 2x squared is the lead, plus 3 is the last, and hopefully in your brain by now, you're able to find that middle term very quickly by doing your bridges and tunnels. Tunnel is 3x, bridge is 2x, so that gets me a positive 5x. I still have the minus 1, so when this cleans up, basically I have (2x squared plus 5x). 3 minus 1 gives me a plus 2. That's a trinomial. Trinomials can get factored into 2 binomials. 2x squared would be 2x and x. And now, here's how you cheat. You're in high school math. This topic is reducing expressions. So guess what? They want you to come up with common factors. So up top here, if this is x plus 2, I bet you this one's x plus 2. They want you to be able to cancel out. So if that's x plus 2, how do I get 2 on the back with a 1? And it's got to be plus because everybody's a plus. And if I do checking, 2x times x gets me my lead of 2x squared. 1 times 2 gets me my back of 2. My bridge is 2x. My tunnel is 1x. Sorry, my bridge is 4x. My tunnel is 1x. 4x and 1x gets me 5x. Okay? Cancel out my common factors. I'm left with 2 over 2x plus 1. Now I have to figure out, well, what would x make a 0 on the denominator? So in other words, 2x plus 1 would equal 0 when that x is a -1/2. So my final answer would be, this reduces down to 2 over 2x plus 1, but x cannot equal a -1/2. It can equal any other number in the world, but never a -1/2. Okay, yes, the last section of chapter 2 was a really, really long video, and here's a really, really short video.